Okay, we're just going to look at this specific situation where you notice the integration, you have the derivative times the function to some power of n. Right. So if you have that situation, then again, you can just add 1 to the power over the power. Because if you're thinking about differentiating this expression I've got on the right hand side here, what would you do? You'd bring down the power, so n plus 1 would cancel with the n plus 1. Lower the power, that would become power of n, differentiate the inside, f dash x. So if you recognise that straight away, then you don't have to use ideas like integration by substitution and things like that. Bang, you can get the answer immediately. Sometimes you see questions like this, by the way, and it gives you a huge hint on how to do the question. They start off with, find this derivative. Oh, okay, let's find this derivative. Differentiate the square root of 1 minus x cubed, and well, I've put it all in third form, minus 3x squared on 2 root 1 minus x cubed. And in this case, you do want to put it in third form, because usually there's going to be a follow-up question. Oh, can you please now go and integrate this? Well, because I put it in third form, I can compare the two and go, you know what? They're very similar. The only difference is that this first one is multiplied by minus 3 and 2. So, okay, let's multiply by minus 3 and 2. But I can't change the question. So therefore, to balance it back out, I'll multiply by minus 2/3. But we know the answer to the square root of minus 3x squared on 2 root 1 minus x cubed, because we just worked out that that's the derivative of the square root of 1 minus x cubed. That's giving a really big hint, but essentially it's the same idea. You're saying, hang on, do I have the derivative times some function to the power? Here's one where the hint wasn't given, but again it involves a surd. Now, 2 plus x squared would be to the power of a half. So the question is, have I got the derivative there already? And pretty close. Derivative of 2 plus x squared is 2x. I don't have 2x, damn. But I'll make it 2x. But then, of course, I have to balance it out. Well, I now have the situation of derivative times the function to some power, that power being a half. Add 1 to the power, 3 on 2. Divide by that same power, so 2/3. And there's our expression. Well, almost. Let's do some tidying. 1/3. And of course, we put in the super mathematician answer rather than leaving it like a mere mortal. Now, you will see this other technique, and we'll look at it in more detail later, but this idea of substitution. And sometimes they tell you the substitution and you're forced to use it. And sometimes they might say, integrate this using the substitution, u equals 2 plus x squared. And that's when you just start crying, you know. Oh, what? Why are you making me do this? So much easier to just go, dang. But all right, if they tell you you have to use the substitution, then you got to use the substitution. All right. But when we substitute completely. There should be no mention of x in my integral at all, which means I've got to work out what du is. Now, normally I wouldn't put that middle line in. I'd probably just go straight to du is 2x dx. But basically, you're just differentiating the u, and you could think of du dx like a fraction. I mean, it's a rate of change, so it's like a fraction. Multiply the other side by dx, balance it out. So now how do I substitute in? Well, there's u, 2 plus x squared, and oh look, I've got x dx, so I've got half of du. So I could rewrite that, and there's no mention of x in there now. I've got this new integral, and it's a simple little one. Add 1 to the power over the power. And you can see the similarity between the two. But of course, the question didn't involve u. We got to get it back to x. So we sub x back in, and we get our answer. Here's another one. The x cubed minus 2 is to the power of something. So we've got some function to a power. The derivative of x cubed minus 2 is, of course, all right, I don't have 3x squared, I've just got x squared. That's fine. We'll make it 3x squared, so I've got what I want. Balance it out, 1/3. I now have the situation of derivative, 3x squared, times some function, x cubed minus 2 to the power, and this is, of course, to the power of negative 3. So I can just add 1 to the power, which is negative 2, over the power, and sub in now 1 and sub in 0, and we get negative 1/8. Now, if I did this via the substitution, there's the same question, of course. We have to eliminate x completely. Now, those limits, 0 and 1, refer to the x values. So if I keep those values, it's not going to work. I've got to change those as well. So how do I do that? Well, that's all right. I've got a little formula there. U equals x cubed minus 2. So when x is 0, u will become negative 2, and when x is 1, u will become negative 1. So now we can substitute in. We have 1/3 the integral from minus 2 to minus 1 of u to the minus 3 du. Now in this situation, we don't have to change back because we're substituting in these new limits. We should get the same answer. So when I substitute in, oh, what do you know? We get minus 1/8 again. But as I say, we'll look at integration by substitution in more detail later. Okay, 5i.